Hello, welcome to our channel. In this episode, we're going to discuss some basic concepts of power amplifier, specifically the class AB power amplifier, and we're going to do some circuit designs, experimentation, and implementations of the amplifier circuit to come up with our desired output so we can compare it to other classes of power amplifier. So, let's get started. So, what is a Class AB amplifier? As its name suggests, the Class AB amplifier is a combination of the Class A and the Class B type amplifiers. The AB classification of amplifier is currently one of the most common used types of audio power amplifier design. The Class AB amplifier is a variation of a Class B amplifier as described above, except that both devices are allowed to conduct at the same time around the waveform's crossover point, eliminating the crossover distortion problem of the previous Class B amplifier. The two transistors have a very small bias voltage, typically at 5 to 10% of the quiescent current, to bias the transistors just above its cutoff point. Then the conducting device, either bipolar or FET, will be on for more than one half cycle, but much less than one full cycle of the input signal. Therefore, in a Class AB amplifier design, each of the push-pull transistors is conducting for slightly more than the half cycle of conduction in Class B, but much less than the full cycle of conduction of Class A.
In other words, the conduction angle of a Class AB amplifier is somewhere between 180 degrees and 360 degrees, depending upon the chosen bias point as shown. The advantage of this small bias voltage, provided by the diodes and resistors in series, is that the characteristic crossover distortion of a Class B amplifier is overcome without the inefficiencies of a Class A amplifier. This means the Class AB amplifier is a good compromise between Class A and Class B in terms of efficiency and linearity, with the conversion efficiencies reaching about 50 to 60%. Now, let us proceed to the actual experimentation.
For this experiment, you will be needing the following materials: a computer running pixel pulse software, analog devices ADAL M1000, solderless breadboard, jumper wires, two 2N3904 NPN transistor, two 2N3906 PNP transistor, four 1.1 ohm resistor, one 100 ohm resistor, and two 1000 ohm resistor.
Placing the 2N3904 amplifier on the breadboard. Connecting a 1 kilo ohm resistor. Connecting four 1.1 ohm resistor in series with the 2N3N04 amplifier. placing a 2N3906 amplifier in series with the 4 1.1 ohm resistors. Placing a lower 1 kilo ohm resistor to ground wire. Placing a lower level shifter 2N3906 amplifier. Placing a lower level shifter collector base wire. Placing a lower base to level shifter wire. Placing a 100 ohm resistor. Placing a level shifter emitter to emitter wire. Attaching the upper level shifter to N3904 amplifier. Connecting a upper level shifter collector to base wire. Connecting a upper base to level shifter wire. Connecting the 5 volts channel, 2.5 volts channel, channel A, channel B, and ground to the ADAL M1K. Set up the M1K to source voltage, measure current on channel A. Set up channel A source waveform for a 50 Hz sine output to swing between 0.5 volts and of 4.5 volts. Set up M1K, measure voltage on channel B.
A Class AB amplifier has a medium distortion compared to the other classes of amplifier and an efficiency between 25% to 79%. The push-pull circuit is biased slightly above cutoff to eliminate crossover distortion. In the case of Class AB amplifiers, crossover distortion can be reduced by using a slight forward bias in the base circuit such that the transistors are idling at a small output current. The forward bias causes the circuit to operate in Class AB mode, so both transistors are slightly on during crossover.